Hello everyone. Today let's prove that under root 2 is an irrational number. So we all know that under root 2 is an irrational number, but in mathematics we'll have to prove it explicitly. Today we will be doing it with a technique called proof of contradiction. What this technique means is that we make an assumption that what we have to prove opposite of that is actually true. So we make an assumption that the opposite of what we have to prove is actually true. Then we follow a line of thought, a line of logic until we reach a contradictory statement, something that contradicts what we already have assumed or what is in general true in mathematics. Proving that what we have assumed that the opposite of what we have to prove is correct, hence proving that what we have to prove is correct. I hope that was clear. A little confusing, but it will get easy once we see the proof. So let's begin with making an assumption that opposite of what we have to prove is correct. That is, under root 2 is a rational number. Now for anything to be rational number, we can say that there exist two integers, say p and q, such that p and q are divisible, can be written in a fraction form. There exists p and q belonging to integer such that p by q is equal to under root 2. This can also be written as p equals to under root 2q, which can also be written as p square equals to 2q square. Okay, let this be our equation number 1. Here we are also assuming that p and q do not have a common factor. What this means is that p and q are written in their smallest possible form. You will understand why we are doing it in coming proof. So from here, from equation number 1, we can see that p square is an even number. Since it has 2 as its factor. Since p square is an even number, we can also write that p is an even number. Now an even number can also be written in the form of 2r, where r is a integer. So we have written that p is equal to 2r. Now let this be our equation number 2. Now let us try to merge equation number 1 and equation number 2. Okay. So we will write p square equals to 2r whole square equals to 2q square. From this we can derive that 4r square is equal to 2q square. Dividing both sides by 2, we get 2r square equals to q square. Now look at this closely. This tells us that q square has 2 as its factor. So this means q square is an even number. This can also be said that q is an even number since q square is an even number. Okay. Now if you notice, earlier we proved that p is an even number Now we are saying Q is an even number. So P and Q both are even number. This means P and Q have a common factor 2. Right? Now this is something that is of our interest because it is in contradiction to something that we had assumed earlier. We had assumed that P and Q do not have a common factor. Right? So this means that our most basic assumption was incorrect, which is under root 2 being a rational number. This assumption is incorrect. Hence, under root 2 has to be an irrational number. So this was our proof. Thank you for watching the video.